Hello everyone, this side Dr. Amit Kumar Pandey. I am going to discuss a very important topic in operating system known as FCFS, CPU scheduling algorithm. The importance of this topic you can understand by this scene that there are number of processes inside operating system and all want to get executed. So there should be a manner or policy by which we can arrange the sequence of execution of all those processes. So one of them is FCFS CPU scheduling algorithm. Let's see one by one what is inside. So basics of FCFS. Basics of FCFS is FCFS is the simplest CPU scheduling algorithm. As the name suggests, this algorithm entertains requests in the order they arrive in the disk queue. The algorithm looks very fair. Means there is no starvation at all, but average waiting time and average turnaround time uh, is something higher in comparison of other CPU scheduling algorithm or strategies. So what are the steps of FCFS? In FCFS CPU scheduling, the process which arrive first get the CPU first. If more than one process arrives at the same time, then the process which have the smaller process ID will give in preference. It is by default non-preemptive in nature, means there is no preemption at all with this policy. Advantage of FCFS CPU scheduling algorithm is that it is very simple and easy to understand the strategy. It can be implemented using queue data structure in an easy manner and does not lead to starvation at all. Disadvantages of FCFS. Priority is not considered and burst time is not considered. If process have the small burst time, then also okay. If have larger burst time, then also okay. Priority is higher, then also okay. Priority is least, then also okay. It never judge on behalf of their burst time or their priority. The logic is very simple. Who arrive first will get the CPU first for its execution. We can see it suffers from convoy effect. What is convoy effect? In FCFS CPU scheduling algorithm, in starting, there are processes which have huge burst time, and after that, there are number of processes which have very less burst time, have to wait for a long period for their execution. This problem is known as convoy effect. Now, take an example and we can understand the working of FCFS CPU scheduling algorithm. Let us see how the FCFS works. We take here, we take here number of processes, some process, and their respective burst time, BT. In first example, we does not take arrival time. So see simple numerical, some process and their burst time. Suppose there are three processes P1, P2, and P3 with their respective burst time 100, 20, and 50. How the process will get executed? Let us see. We make a Gantt chart for execution. Here are three processes. So we divide this into three parts. Here, arrival time is not given. then we assume that when the CPU start execution, all the three processes are available for their execution. So if CPU start from 0, then arrival of P1 is first. When arrival time is not giving, then we consider the sequence as written in the numerical like their arrival sequence. So here P1 will get execute first. P1. What is the burst time of P1? It's 100. So 100. Now P2 will get execute. P2. What is the burst time of P2? It's 20. Now total time will be 120. And in the last, P3 will get execute. P3. What is the burst time of P3? It's 50. So total time here will be 50 plus 120 equals to 170. Our Gantt chart is prepared. So in every numerical, the common asking is average waiting time and average turnaround time. So let us see what is average waiting time. Average waiting time and average turnaround time. For average waiting time and average turnaround time, we should have individual waiting time and individual TAT. So for waiting time, we get individual. Here we get individual. Individual waiting time. So individual waiting time for P1 will be 0 because P1 is not wait anymore for its execution. So P1 0 unit time. For P2, this will be 100 according to Gantt chart 100. So we write here 100. And for P3, this will be 120. Waiting time is 120. So what will be the average waiting time? Summation of I equals to 0 to n pi wt divided by number of process. So this will be 100 plus 120 equals to 220 divided by 3. So this will be 73 point something unit time. So we can see what is the average waiting time. Average waiting time is 73 point something. And if we talk about turnaround time, so what is turnaround time? Turnaround time basically turn around time is basically waiting time plus their burst time or execution time. So individual TAT for P1, for P2, and for P3. For P1, it will be waiting time of P1 is 0 plus burst time of P1. Burst time of P1 is 100. Burst time of P1 is 100. So 0 plus 100. 0 plus 100 will be 100. For P2, what is the waiting time of P2? Waiting time of P2 is 100 and burst time of P2 is 20. So 100 plus 20, 120. For P3, it will be 120 plus 50. It will be 120 plus 50. So this will be 170. We can see this also from Gantt chart. This is the waiting time P1 0, P2 100, and P3 120. And this is the turnaround time P1 100, P2 120, and P3 170. So what you have to do for average turnaround time? You have to sum all these values and divide by 3, which are the number of total processes inside the system. So this way you will get the average TAT, average turnaround time. I think this is clear to all of you. Now take again an example. Process their respective burst time BT and their respective arrival time. Arrival time, in last example, we does not take arrival time, but in this, we take arrival time to see what will be the change. P1, P2, and P3, and bus time 100, 20, 50. We keep the bus time same as previous example. And suppose arrival time is 0, 10, and 30. So what will be the change? Okay, what is question? The common asking is same. We are asked for AWT, means average waiting time, and ATAT. Okay. So let us see. First, we have to calculate individual waiting time for all. So for that, we prepare a Gantt chart here. Okay. FCFS is by default non-preemptive in nature, so there is no preemption. So according to arrival time, the logic of FCFS is that the process arrive first will get the CPU first. So who tell us that, which one of P1, P2, P3 among all the three comes first? So arrival time column will provide us information who arrived first, who arrived second, and who arrived in the last. So according to arrival time column, as we can see, the P3 arrived first at arrival time 0. So we execute P3 first here. P3, as this is non-preemptive, so process will release the CPU on its complete execution. So P3 will execute for the 50 unit time. So here time is 50 unit. Now who comes on the second number? This is P2. So now we run P2. What is the burst time of P2? This is 20. So the total time will be 50 plus 20, 70. And who comes in the last? This is P1. Now we execute P1. What is the burst time for P1? It's 100. So total time will be 170. Okay. P3, then 50, then P2, 20 for 20 unit time, then in last P1 for 100 unit time. Our Gantt chart is prepared. So calculate average waiting time. So there are two methods for getting individual waiting time. You see, according to chart, waiting time for P1, for P2, and for P3 is for P1, this is 70. For P2, this is 50. And for P3, this is 0. But these are not the correct waiting time for all the processes P1, P2, and P3 because in Gantt chart, the waiting time is calculated from the starting, from the 0. And P1, P2, P3 all did not come at time 0. So we will minus arrival time of these processes, respective arrival time. So arrival time of P1 is 30. You can see here 30. So this will be 70 minus 30 equals to 40. And for P2, this is 10. So 50 minus 10 equals to 40. And for P3 is 0. So 0 minus 0 equals to 0. So these are the actual waiting time for P1, P2, and P3. Now we have to calculate turnaround time. So TAT for these processes will be for P1. This will be waiting time, which is 40 plus burst time of P1 is 100. Waiting time plus burst time. This will be 140. And for P2, this will be 40 plus burst time of P2 is 20. So this will be 60. And for P3, this will be 00, which is the waiting time for P3 plus burst time of P3 is 50. So this will be total 50. Now, we were asked for AWT, average waiting time, and average turnaround time. So if we get individual waiting time for P1, P2, P3, and individual turnaround time for P1, P2, P3, then there is nothing to do more. For AWT, we add all the numbers, all the waiting time, all the individual waiting time, which will be 80 divided by number of 3. And for 80, we will add all the individual turnaround time of P1, P2, P3, which will be 250 divided by number of process 30. So we saw two numericals. one without arrival time column and one with arrival time column. So in this way, we will find out the average waiting time and average turnaround time for number of processes in numerical. The main important thing is keep in mind that FCFS is by default non-preemptive. So preemption will not be done in any case. This is non-preemptive FCFS. Okay. So we will move next and see another example. Here is another example, numerical, in which there are number of processes, means 5 processes, P1, P2, P3, P4, P5, and their respective arrival time and respective burst time. So asking is same. We have to find out average waiting time and we have to find out average turnaround time. So we prepare a Gantt chart for that. We can see here which come first at arrival time 0, P3. So P3 will get execute first. What is the burst time of P3? The burst time of P3 is 2. So you can see here 0 to 2. Now on after 2 unit time, processor will check if there is any other process which want to get execute. So you can see in this arrival column, there is no process which arrives after 2 unit time, on 2 unit time. So processor have to wait for next process. So next process, the earliest process which come on 3 unit time. So you can see here, processor have to wait for 1 unit time. 1 unit time. After 3 unit time, there is a process called P1. So processor will execute P1 for 4 unit time as FCFS is non-preemptive. Then you can see here at after 5 unit time, there are two processes which arrives at the same time after 5 unit time, P2 and P4. So which will get executed first? In this scene, the process which have a smaller process ID will get executed first. So P2 will get executed first, and after that P4 will get executed. P2 and P4. And meanwhile, between 5 and 3, there is P5. So P5 is also executed between P1 and P2, P4. So this is the Gantt chart. Now this is very easy to find out the individual waiting time and individual turnaround time using this Gantt chart. So here you can see this is the another method using exit time. So what is the exit time? You can see here exit time is this. Exit time or completion time. For P3 it will be 2. For P1 this will be 7. For P5 this will be 10. For P2 this will be 13, and for P4 this will be 14. So first note down the exit time. P1 7, P2 13, in this way 7, 13. Note down exit time for all the processes. How can you get turnaround time? So turnaround time for individual process will be the individual exit time of that process minus arrival time of that process. So here 7 minus arrival time of P1, here 13 minus arrival time of P2, in this manner, same for all. V minus their arrival time. So after deducting arrival time, we will get turnaround time, individual turnaround time. And how we get waiting time? So we again minus bus time from that turnaround time. This will give us individual waiting time for all the processes. Okay. When we get average turnaround time and when we get individual turnaround time and individual waiting time of the processes, then this is very easy to calculate average turnaround time and average waiting time for all those processes. Simple, add all the turnaround time of all the processes and divide by total number of processes, and same for waiting time. Sum all the individual waiting time and divide them by number of processes. So in this way, we will get average turnaround time and average waiting time for all the process. Here are some references which I have used in my lecture. Thank you so much. Thank you all.